So we're going to solve more log equations today. Okay, so first question. Log x base 6 plus log of x plus 1 base 6 equals to 1. Okay, so we're going to try out a new rule. Okay, so let me write down the rule first. Okay, whenever you have log a, let's say base b, plus log c base b, this can be combined into log of a times c base b. Okay, so this works if they have the same base. All right. What about for subtraction? Okay, what if I have log a base b minus log c base b? Then this is equivalent to log of a divided by c base b. Okay. And one more rule that we will use today is the change of base. Okay, so how do we change the base, right? So sometimes we are given a particular base, but we don't want that, right? We want some other base. So how can we change the base? Okay, so for example, right, let's say I have a log a base b. Okay, and I don't want base b. Maybe I want base c. Okay, so this is how I change the base, right? So this is equivalent to log a base c divided by log b base c, right? So c can be your choice, right? Your choice of number, right? Any real number, except negative and 1, all right? So the base cannot be 1 and it cannot be a negative value, right? But other than that, you can choose any real number. Okay, so we're going to use these 3 rules today to solve the equations. Okay, so let's go back to question 1. All right, so notice that I can use the first rule. Okay, so maybe I should indicate first rule, second rule, third rule, right? So just for the sake of reference for this video. Okay, so how do I combine them together, right? So using the first rule, this is equivalent to x times x plus 1. Okay, so this is power 6 equals to 1. All right. So if you remember the previous videos, right, we already talked about this. So x times x plus 1 is equals to 6 to the power of 1. Right, so x times x plus 1 is equals to 6 to the power of 1. So x squared plus x equals to 6. So x squared plus x minus 6 is equals to 0. Okay, so it's quite easy to factorize this. So let me factorize this. Okay, so this is x plus 3, x minus 2 equals to 0. So x is equals to negative 3 or x is equals to 2. Okay, so notice that, okay, negative 3 has to be rejected, right? Because we cannot log a negative value. Okay, so as usual, always remember to substitute the value back into the original equation. Okay. All right, so that is question 1. Let's go on to question 2. Log 16 base x plus log 4 base x equals to 2. So this is very similar to the first question. Okay, so I can combine this together. So 16 times 4 is 64, right? Base x, and that is equals to 2. So 64 is x to the power of 2. And x is equals to 8 or negative 8, right? So again, negative 8 is rejected because we cannot have a negative base. Okay, so base cannot be 1 and it cannot be negative. Okay, let's go on to question 3. Okay, so it's quite a handful. So for this question, I'm going to use the second rule. Okay. So this is equivalent to x minus 2 times 8 minus x divided by x minus 5, right? Base 8 equals to 1. Okay, so let's expand this out, right? So x minus 2 times 8 minus x. Okay, so that is 8x minus x squared minus 16 plus 2x over x minus 5 equals to 8 to the power of 1, right? So we can multiply both sides by x minus 5. Let me simplify the top as well, so I can save some steps. Right, this is negative x squared. 8x plus 2x is 10x. Minus 16 equals to 8x minus 40. Okay, so x squared minus 2x minus 40 plus 16, that will be negative 24, okay, equals to 0. All right, so this whole thing is simplified to this quadratic equation. Now, is it possible to factorize this? Let's try. Okay, I think I can use x minus 6. No, x plus 6. Yeah, no, should be x minus 6 and x plus 4. Okay, that should work. Okay, so x is equals to 6 or x is equals to negative 4. Okay, so, well, I guess we should reject negative 4, right? Why do we reject negative 4? Because if you substitute x equals to negative 4 into the original equation, okay, so let's say you substitute into this one, you will get negative 4 minus 5, which is negative 9, right? You can't log a negative value. Okay, so we have to reject negative 4. So the answer is x equals to 6. Okay, so let's move on to the fourth question. Okay, I think I would erase one of the questions or maybe two of the questions because I have 5 questions to talk about. Okay, the fourth question. What's the fourth question? Log base 2x is equals to 3 log 2 base x, right? So this is an example where I have to change the base. Okay, so this is base 2 and this is base x, right? So it's not easy to solve it unless I change the base. So what should I change the base to, right? Should I change everything to base 2 or should I change everything to base x? Okay, actually, it doesn't really matter, right? So let's try to change everything into the same base. Okay. So in this example, I think I would just change everything to base 2. Okay, so on the left-hand side is really base 2, so let's not touch that. Okay, so on the right-hand side, how do I change this to base 2? So this is log of 2 base 2 over log x base 2, right? So I'm simply just using rule number 3. Okay, so you realize that log 2 base 2 is equals to 1, right? So we have this. This is 3 times 1, which is 3. 3 over log x base 2. Now I can multiply both sides by log x base 2, and I will get this. Okay, so sometimes you may also want to use a substitution. For instance, you can let y be log x base 2, right? But that's up to you. Right? So I prefer to just do it straight away. Okay, so this is equals to 3. Okay, so log x base 2 is positive root 3 or negative root 3. Okay, so x is 2 to the power of root 13. or x is 2 to the power of negative root 3. Oh, sorry, I think I made a mistake. This should be root 3. I don't know how I got root 13. Okay, so this is root 3, right? 2 to the power of root 3. Okay, so I already checked. If not wrong, both answers are accepted, right? But if you want, you can check yourself. Okay, so that's question 4. Let me erase question 3. I need more space for question 5. Okay. Okay, question 5. Log of 3x plus 1 base 9 equals to log 2x base 3. Okay, so quite similar to question 4. We want to change everything to the same base. Okay, so I think in this case, I would choose to change everything to base 3. Okay, so this is log 3x plus 1 base 3 divided by log base 3, 9. Okay. So log 9 base 3 is actually log 3 square base 3. Okay, so let's do a little bit of side working here. So if you want to change everything to base 9, that is also fine, right? There's nothing wrong with that. Okay, I just love working with smaller numbers because I know that 9 is 3 to the power of 2. Okay, so log 9 base 3 is equals to log 3 square base 3. And that is equals to 2 times log 3 base 3, which is just 2. Okay, so let's simplify this. Okay, so now we have log 3 log base 3, 3x plus 1 divided by 2, and that is equals to log 2x base 3. Okay, so let's multiply 2 to both sides of the equation. We'll get log 3x plus 1 base 3 equals to 2 times log 2x base 3. Okay, so I'm running out of space. Okay, let's continue here. I can move this constant multiple to become the power of 2x. Okay, so let's do that. It's 2x plus 1, and if I bring this 2 up, right, so it'll be the square of 2x. So 2x squared is 4x squared. Okay, so 2x plus 1 has to be equals to 4x squared. Okay, so now we have another quadratic equation to solve. Okay, so let's try to do it. Anyway, the answer is not so nice. It's actually an irrational number. So don't bother trying to factorize. So you can use the quadratic formula or completing the square. Okay, so I already solved it and I got x equals to negative root 5 over 4 minus 1/4, or root 5 over 4 plus 1/4. Oh, sorry, I think this is a plus, right? Yeah. Okay. Okay. All right, so you can see whether you need to reject any of the answers. Okay, so if you don't have to, then both of them are the answers. Okay, so I'll leave that to you to check. Okay, so that's it for this video. See you in the next one. Goodbye.